Lesson: AI and decision support systems. Artificial intelligence has become a cornerstone in enhancing decision support systems, enabling businesses and organizations to make informed decisions by analyzing large volumes of data. AI in DSS is not just about processing data, but also about deriving actionable insights that can lead to strategic advantages. This lesson delves into practical tools, frameworks, and step-by-step applications that professionals can implement to address real-world challenges effectively. AI-driven decision support systems leverage machine learning algorithms to analyze historical data, identify patterns, and predict future trends. These systems are designed to simulate human decision-making processes by incorporating data analytics, statistical models, and optimization techniques. The integration of AI in DSS provides several benefits, including improved accuracy, speed, and consistency in decision-making. For instance, a study conducted by McKinsey Company found that organizations that effectively use AI in their decision-making processes can achieve a 10% increase in revenue and a 20% reduction in costs. One of the most potent tools in AI for decision support systems is machine learning. Machine learning algorithms, such as decision trees, support vector machines, and neural networks, are widely used to predict outcomes based on historical data. For example, in the healthcare industry, AI-enabled DSS can predict patient outcomes by analyzing data from electronic health records. This predictive capability allows healthcare providers to identify high-risk patients and allocate resources more effectively, ultimately improving patient care and reducing costs. A practical application of machine learning in DSS is the use of the Python programming language, which offers libraries such as scikit-learn and TensorFlow. These libraries provide pre-built algorithms and models that can be easily integrated into existing DSS to enhance their predictive capabilities. Another essential aspect of AI in DSS is the use of natural language processing to facilitate human-computer interaction. NLP allows users to interact with DSS using natural language, making the systems more user-friendly and accessible. For example, chatbots powered by NLP can assist decision-makers by providing real-time information and answering queries in a conversational manner. This capability is particularly useful in customer service, where chatbots can handle routine inquiries, allowing human agents to focus on more complex issues. The implementation of NLP in DSS can be achieved using tools such as Google's Dialogflow or IBM's Watson Assistant, which offer robust platforms for developing conversational interfaces. Incorporating AI in DSS also involves the use of optimization algorithms to find the most efficient solutions to complex problems. Optimization algorithms, such as genetic algorithms and simulated annealing, are used to solve problems where multiple solutions exist, and the goal is to find the best one. For instance, in supply chain management, AI-driven DSS can optimize inventory levels by considering various factors such as demand forecasts, lead times, and storage costs. By implementing optimization algorithms, businesses can minimize costs, reduce waste, and improve overall efficiency. Software tools like MATLAB and R provide comprehensive environments for implementing optimization algorithms, offering a range of functions and toolboxes specifically designed for optimization tasks. The application of AI in DSS is not limited to prediction and optimization. It also extends to data visualization, which plays a crucial role in interpreting complex datasets. Effective data visualization helps decision-makers understand data patterns and relationships, facilitating more informed decisions. AI-powered data visualization tools, such as Tableau and Power BI, offer advanced features that enable users to create interactive dashboards and reports. These tools use AI algorithms to automatically suggest the best visualization techniques based on the dataset, making it easier for users to identify trends and outliers. By integrating data visualization into DSS, organizations can enhance their ability to communicate insights and support data-driven decision-making. Case studies further illustrate the effectiveness of AI in DSS. A notable example is the use of AI in the financial industry, where AI-driven DSS are employed to detect fraudulent transactions. By analyzing transaction data in real time, these systems can identify anomalies and flag suspicious activities, thereby preventing fraud. According to a report by the Association of Certified Fraud Examiners, organizations that use data analytics and AI for fraud detection can reduce fraud losses by up to 50%. This demonstrates the tangible benefits of integrating AI into DSS to address specific industry challenges. To successfully implement AI in decision support systems, it is crucial to follow a structured approach. The first step is to define the problem and the objectives of the DSS. This involves identifying the key decision variables and the data required to support the decision-making process. Once the problem is clearly defined, the next step is to collect and pre-process the data. Data pre-processing involves cleaning and transforming the data to ensure it is suitable for analysis. Tools like Python's Pandas library can be used for data pre-processing, offering functions for handling missing values, encoding categorical variables, and normalizing data. After pre-processing, the next step is to select and train the machine learning models. This involves choosing the appropriate algorithms based on the nature of the problem and the data characteristics. For example, if the goal is to classify data into distinct categories, algorithms like decision trees or support vector machines may be appropriate. On the other hand, if the goal is to predict a continuous variable, regression algorithms or neural networks may be more suitable. Once the models are trained, they should be evaluated using metrics such as accuracy, precision, and recall to ensure their effectiveness. The final step is to integrate the AI models into the decision support system. This involves developing an interface that allows users to interact with the models and obtain insights. The interface should be designed with the end user in mind, ensuring it is intuitive and easy to use. Additionally, the system should be continuously monitored and updated to ensure it remains relevant and accurate as new data becomes available. In conclusion, AI in decision support systems offers significant advantages in terms of accuracy, speed, and consistency in decision-making. By leveraging machine learning, natural language processing, optimization algorithms, and data visualization, organizations can enhance their decision-making processes and gain a competitive edge. Practical tools and frameworks such as Python libraries, NLP platforms, and data visualization software provide the necessary resources for implementing AI in DSS. By following a structured approach and considering real-world examples, professionals can effectively integrate AI into their decision-making processes and address complex challenges across various industries.